Hey, what's going on, guys? In this video we are going to talk about signals and system. Now let's look at the definition of the signals first. Signal is dependent variable or function of one or more independent variables. Now let's look at an example. Let's say we have a function that has dependent variable like x1, x2, x3 until x of xn. This f is the signal, right? This is signal, and these are independent variables. Independent variables. Okay, now let's look at the definition again. Dependent variable, signal is a dependent variable or function of one or more independent variables. So you can see this is function of one or more independent variable. That's called signal. And also you have to know the difference between constant and the signal. For example, if you take AC current is a signal because as the time change, the current is changing, right? Because time is the independent variable. As the time changes, the current is changing. So this is a signal. So we can say AC current is a signal, but DC current is a constant. DC current is a constant, therefore this is not a signal, because as the time change, the DC current doesn't change, so this is a constant. So these are the things we have to know. And also we have to know there are two types of signal. The first type is we can have single variable signal. Single variable signal, and the second type is multivariable signal. Multivariable signal, as the name states, you can see single variable signal is the signal that is dependent on one independent variable. So for example, we can say f of x or g of t. This is a single variable signal. And for the multivariable signal, let's look at some example. We can say f1 of x1, x2. This is a multivariable signal because we have more than one independent variables. So this is a multivariable signal. Or we can say g1, t1, t2, t3. This is also a multivariable signal. So this is what signals like. This is how we define signals. Now let's look at the system. System is the meaningful interconnection of physical devices and components is called as system. Let's look at the definition again. The meaningful interconnection of physical devices and the components is called as system. Now let's look at an example. Here we have a system. Let's put this one as a rectangular box. System alone cannot do anything. Okay, in order to make the system function, we have to give a signal. For this motor, we have to give electricity. So electricity is the signal. So this is input signal. So generally we can say to make the system function, we have to give an input signal. Signal input. And after we give the input signal, after it processed through the system, it's going to give an output. In our case, that's going to be mechanical work because we need to pump this water to this tank. So we have to give them this. This will give mechanical work. Mechanical work, and this is called output signal. So signal output, right? In this case, output signal is more desirable than the input signal because we need mechanical work. That's the most important thing to pump this water. But this is not always true because sometimes electricity can be more desirable than the output signal. Okay, in this particular particular situation, this output signal is more desirable. And also when we deal with signals and system, there are two types of problems we can have. Analysis problem, and the second one is synthesis problem. Analysis problem, we will be given input signal, and also we will have system. we have to find out what is the output signal is, right? And for synthesis problem, we will be given input signal and we have to find out the system, and output signal will be given. So this one is more complicated because sometimes the system may or may not exist, so it's going to be a little bit complicated, but this one is okay. And those are the things we had to know about signals and system. I hope this helps. Thanks for watching.